Peer Clois Thermal Pisa Hissing Paschimi Afriki Rend Kuimenti Real channel. You can practice more problems on this exact topic on our Padhai Karlo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is classifying redox reaction types, and the systematic ion-electron method for balancing redox equations. Let's begin. Redox reactions genuinely fall into several distinct structural categories. Combination reactions, where two or more elements combine to form a single compound, like hydrogen and oxygen forming water, are genuinely always redox, since elements start at oxidation state 0, and end up with non-zero values. Decomposition reactions, where a single compound breaks apart into two or more simpler products, are redox, specifically when at least one product is an element in its zero oxidation state, like the electrolysis of water breaking apart into hydrogen and oxygen gas. Displacement reactions, where one element in a compound is genuinely replaced by another element, are essentially always redox. A classic example being zinc metal displacing copper. From copper sulfate solution, zinc is oxidized while copper ions are reduced. Disproportionation reactions form a genuinely special fourth category, where a single element in one specific intermediate oxidation state is simultaneously oxidized and reduced within the exact same reaction. Some atoms or that element go up in oxidation number, while other atoms or that identical element go down. A genuinely classic example is chlorine gas. Oxidation state 0 reacting with cold dilute sodium hydroxide producing chloride ion. Oxidation state -1 the reduced product, and hypochlorite ion. Oxidation state +1 the oxidized product, both forming from the exact same starting chlorine simultaneously. Recognizing this pattern genuinely requires checking whether a single element appears in the SME starting oxyp across multiple different product species, with gene infil in fermentinchal oxtates here. Clois thermal pisa hissing Paschimi Afriki Rendinavian Leoni, that distinguishes disproportionation from the other three reaction types. Pan-electron method balances even complicated redox equations reliably. First, split the overall reaction into two separate half reactions, oxidation and reduction, then balance every element other than oxygen and hydrogen, / then balance oxygen atoms by adding water molecules, then balance hydrogen atoms by adding H+ ions in acidic medium. Peer Clois thermal pisa hissing Paschimi Afriki Rendinavian Leoni basic medium / then balance the actual electric charge on both sides by adding electrons, and finally multiply each half reaction by whatever specific factor makes the number of electrons genuinely equal in both half reactions, before adding them together and cancelling them together and cancelling anything common on both sides. A frequently tested trap involves genuinely forgetting to convert H+ into O- correctly for basic medium reactions. Remember, add water equal to the number of H+ ions on both sides, combine H+ and O- into water on whichever side they both appear. This systematic conversion prevents errors in basic medium redox balancing specifically. Let's recap. Redox reactions fall into four structure plus: combination, decomposition, displacement, and disproportionation, where the same element is simultaneously oxidized and reduced. The ion-electron method balances complicated redox equations systematically, splitting into half reactions, balancing atoms, then oxygen, then hydrogen, balancing charge with electrons before combining them with equal electron counts. Recognizing the reaction type and following the systematic balancing steps in order prevents nearly all common errors. That's classifying redox reactions and the ion-electron balancing method. Keep the four reaction types and the systematic balancing steps sharp. They turn intimidating redox equations into a mechanical process. If this video helped, please like it and subscribe to Padhai Karlo for more JEE preparation content just like this. See you in the next one.